This is index office hours 59, and it is the 3rd of May, 2022. So we are very excited today to speak about a lot of different things. There is a very packed agenda, as always. I feel like I always say that, but there's always some fantastic and interesting things that we talk about on this show. So we do love participation, so if you would like to participate via voice or text, please do request to be added to the stage. Of course, if you're already on the stage, feel free to unmute your mic and participate in today's conversation. So as always, we love and appreciate all of your participation and contributions, and so we will be rewarding you with a POAP at the end of the episode. Just listen out for the secret word that we'll mention. Download the POAP app and claim your POAP. There you go. So with that out of the way, let's get straight into today's episode. So I'm going to kick off with the opening remarks. There's a lot that we need to cover, but I'll always kick off with the 𝗨𝗲𝗂𝗧 shout out. So this week it was episode 62 with Kent, who's this co-founder and CTO of 𝗨𝗂𝗂𝗧𝗂𝗂, which, by the way, I think is a cool name because it's a combination of the graph and Africa. So Kent is super passionate about Web3, the graph, and the African continent. He has a technical background and spoke a lot about his perspectives on blockchain and how it could empower the continent that is Africa. He spoke a lot about mining, subgraphs, graph grants, and where he thinks the general future of the graph ecosystem is going. And so if you're interested to hear that perspective, I highly recommend checking out the 𝗨𝗲𝗂𝗂𝗧𝗂𝗂 podcast. So with next announcement is obviously Graph Day, which is happening the 2nd of June. Make sure you're there. It's going to be a fantastic time. I'm very much looking forward to being there and seeing many of you in person. So if you haven't got your tickets, make sure you do go ahead and get those. There's also going to be a hackathon happening from the 3rd of June to the 5th. Tons of great things I'm sure are going to be built, so be sure to be there. So that is it for opening remarks. I see, wow, quite a few people here, which is very exciting. Without further ado, I'm going to hand it over to Anna, who's going to take us into Repo Watch.
Welcome to our regular segment, Repo Watch. As always, you will find links to release notes and PRs in the agenda that was published. And before we start with major blockchain clients, I want to remind you that we've recently updated the flow a bit, so we only mention the clients that have had new releases. So if you don't hear of a client, then it's because it hasn't had any new releases, but you will see the repo with the last release on the Repo Watch agenda. So looking at major blockchain clients, we have had, again, new change to 𝗟𝗏𝗀𝗀 version 2. So recently, 𝗟𝗏𝗀 was split between versions 1 and 2. And this week, we've had a new release for version 2, so version 2022.04.04 alpha. It contains a lot of fixes, but some that are worthy to mention. So fixes to improve download speed of the block snapshot files. So previous release had a limitation, meaning that most users saw download speed limited to 2 megabytes per second, which I know it's been reported in the IOH as well. The sync mode fast has been renamed to sync mode full in the command line arguments to avoid confusion. A new service called ETHstat has been added, and first version of Observer, which is a P2P network crawler, has also been added, and this is a precursor for an open source node explorer. Then there's an admin peers method, RPC method, to collect information about connected peers, plus additional fixes and networking changes related to BitTorrent. Before we move on, has anyone tried this release, so 2022.04.04 alpha? And if you have, what kind of experiences have had with it?
Well, I'm running a node. Was able to sync it. Seemed to be running pretty well. One interesting thing to note is that the storage requirement is significantly lower, so that's good for us. Um, I still have to test it with Graph Node, so that's my plan for the next couple of days.
Thank you for the insight there. That's interesting to know about the storage. I'm sure many people will be happy with that. Anyone else? I will take that as a no. Okay, in this major blockchain clients section, we've also had some big changes from the Firehose team. So the full announcement is linked onto the repo watch, but some really brief overview, and I'm sure we will cover this in more detail in the future. So what you need to know is that the Graph team has recently conducted some testing to certify Firehose on Ethereum as perfectly compatible with the Graph current data acquisition over JSON RPC. And the tests conducted have revealed some discrepancies from data returned by Firehose. So the discrepancies were the gas price was being always reported as the max gas price that the user would be willing to pay. And on the newer transaction type, JSON RPC returned the effective gas price, so block space fee plus gas tip, and not just the max gas price. And then another discrepancy was the total difficulty was not indexed. So the total difficulty method was not indexed as part of the blocks header while it's available and used in GraphNode. And based on these two discrepancies, there's been loads and loads of changes. But what operators need to know is that the develop branch is able to produce block V2 only, which is still able to decode already stored block V1 format. So basically everything that's on develop branch is version 2, and from now on the two different releases will be version 2, which addresses some of the discrepancies. So moving forward, there's any release that ends with Firehose 1, which is the release you'd want to use in production, as it's the stable release. And Firehose releases ending in Firehose 2 will be for Firehose version 2 for more alpha-like releases. So with that, on Streaming Fast Get version 1, as in Firehose 1, we have two new releases. So BSC version 1.1.9, Firehose 1, and Get version 1.10.17, Firehose 1. So these would be the releases that you're using in production. And for Streaming Fast Get Firehose 2, we have two new releases as well. So BSC version 1.1.9, Firehose 2, and Get version 1.10.17, Firehose 2. Now, I appreciate that I spoke very fast, so let's see if there's any questions or if anyone has tried any of these releases, and if anyone from Firehose wants to comment on what I just said. I tried to keep it short, but yeah. So talk to me, please. Anyone?
We have not, but we intend to.
Thank you, Kai.
Yeah, I just wanted to just make one small clarification. The kind of 1-2 delineation is really about the flat files. So all of the flat files that the instrumented node spits out, and that are then consumed by the Firehose process to serve the gRPC streams. So at some point to migrate from Firehose block version 1 to Firehose blocks version 2, there'll be a kind of either the need to resync and regenerate all of those files, but more likely sync those from peers somehow. Yeah.
Thank you for that clarification, Chris. Okay, so as I said, I'm sure we will cover this in more detail. So if there is nothing else to add, I think I heard someone wanted to add something. I'm sorry, we can't hear you.
I think that somebody might be on mute by mistake. I don't think that's a person trying to speak, but yeah, just want to double check.
Okay, in that case, moving on to the rest of the major blockchain clients, no new releases. On the Graph stack, so for GraphNode, no new releases. The last release we had was 0.26.0. However, 2 pull requests that we talked about last week. So pull request 3490 has been merged, and that assumes that any messages with revert in them are deterministic errors to avoid having to whitelist all messages. And then we also have pull request 3483 that we covered last week, so that has been merged as well. And this is a better error handling when retrying the same Ethereum Firehose block over and over again with an exponential backhalf, whereas before GraphNode would have been completely crashing. We have a new release for indexer service and agent, so version 0.19.2, which is a pre-release, and most of this version contains changes to indexer native, and what those changes are. So for ARM-based machines, you can now build the indexer native module from source. So, and precompiling is still not supported for those ARM-based machines. And the install mechanism for indexer native now uses precompiled binaries for all other packages. And there have been upgrades to the Neon cargo dependencies to improve the Rust development workflow. Thank you to everyone who's worked on this. It was mainly Ford, but yeah. Has anyone tried this release?
My sound just cut off almost completely for a while. I think Discord is either my network or Discord having issues.
But can you guys hear me?
I can, yeah.
Yeah, I can hear you too.
Same.
Okay. Okay, so anyone else has tried it? Indexer service and agent version 0.19.2 pre-release?
I haven't, but I'm excited to, because this is probably going to have, for us who are building, on bare metal or whatever, building the agent ourselves, it's going to be, I suspect it's going to resolve a lot of the gremlins that we've had in the past around permissions and stuff like that.
Yes, that's awesome. Okay. If nobody has any more comments about any of the releases we've covered today, I am ready to hand over to Protocol Watch 1.
Thanks, Anna. So for this episode in Protocol Watch, we have a ton of stuff to cover, but we want to keep it short to make some room for the fireside chat. So I'll try to be brief. Contract repository, no new updates since last IOH. For the network subgraphs, I tried to split this one into the different subgraphs that are being updated, since just keeping it in a single category wasn't going to cut it. For the core network subgraph, there was a critical issue last week, which we fixed, and we released a new full fix, because the original fix was just a hot fix or workaround. The new release will add an improved fix for the manifest parsing issue. Basically, the subgraph broke because of some subgraph which was published, which did not have a proper manifest, and it was causing some issues with parsing. And it also added some extra query fee data for the epoch entities. On the analytics subgraph, no new releases since last IOH. And on the billing subgraph, we added a new fix for the delta values on all entities. For those that don't know, billing subgraph tracks all the data related to the Polygon GRT billing stuff. So yeah, it's quite interesting, and it now has a few new updates, as well as analytic styles data for like daily data and stuff. Going into forum governance, we have new GIPs, one of which is the Arbitrum GRT bridge. This is related to auto-scaling. It's a custom bridge for GRT so that it could be used in a way that we want to use it in a possible L2 implementation for Arbitrum. It's a huge GIP, so I'd recommend you, if you're interested in scaling, it's a really nice read. Next, we have GIP28, subsidized query settlement. There were a few comments from 𝗟𝗀𝗃 and Brandon regarding the feedback provided by the indexers. All in all, everyone is on board with the feedback that was provided. There are a few reasons as to why some of the design considerations were originally taken, I guess. But it's being heard that the centralization aspects of the gateway and some other, particularly the problematic, I guess, indexing reward distribution based on query fees or not, it's problematic. So yeah, there's a lot of feedback there, and yeah, we're trying to find a better way to handle it. Kai, you were going to say something?
No, sorry, I bumped the push to talk key.
No worries. Next up, the reward forced close mechanism, or stale allocation as we know it. There's a new small comment from Brandon regarding some of the feedback that was brought up by Zach. Then Ariel updated the proposal to change the indexer cut mechanism. This is going way back to one of the original proposals in the forums. He basically commented asking whether or not there was still interest in a proposal to change the indexer cut mechanism to a more, let's say, stable mechanism, and if someone was interested in coding it, basically. Another new GIP, signal renting. This one is quite related to the principal protected bonding curves GIP, because it actually requires principal protected bonding curves for it to work. It's also a huge post. I recommend that anyone that is curious goes and read it, because it's also a really nice read. It's a GIP from Howard, so yeah. GIP24, query versioning. There's another small comment from Brandon related to whether or not the registry is even required, given all the considerations on the arbitration charter, mostly in regards to the required infrastructure for arbitrators to properly validate the POIs. Next up, GIP30, minimum curation amount for indexing rewards eligibility. There's a question from Jim regarding whether there was already a parameter for this, and if this is something new, I guess. I think Ariel responded to that, Jim. If you have any other questions, yeah, let me know.
Yeah, I just wanted to make sure I understand that, because it's so there's an existing threshold on the oracle, the subgraph oracle, so that it doesn't have to deal with noise below subgraphs.
100, yeah, GRT.
With 100 GRT signaled, right? So how is that different in terms of a gating mechanism to this new proposal? That's what I'm trying to understand. Are they very different areas of the I guess the components of the system? Is that why one is not usable for the purposes of the other, or they just don't achieve the same goals?
I think the new GIP adds another parameter which requires a threshold of curation before the subgraph is eligible for basically indexing rewards. So if a subgraph is under that threshold, it will not get distributed the indexing rewards, basically inflation rewards from the protocol. It will just not happen. Whereas the SAO or the Oracle, as you mentioned, I think it just does not care checking whether a subgraph with less than 100 GRT will be eligible or not, will be denied or not, actually.
I think that the kind of key difference is that low signal subgraphs, as in, you know, if we define that as subgraphs below the SAO threshold, are eligible for indexing rewards by default. And it's just not worth, you know, the spam risk to test those subgraphs given such a low degree of signal. So really this proposal changes that, you know, if you are under the minimum signal threshold, then, you know, you don't even need to be considered by the SAO because you're not eligible for rewards.
I think it's also notable to say that it's not that the minimum curation amount has to do with the SAO per se. It has to do with some research that was being done regarding an attack vector, which was released, I think, a week ago or so in the forums, and has to do with, I think, how difficult or how expensive it is to index something and how easy it is to manipulate the rewards or something along those lines, which the minimum curation amount that is added in this GIP would like make it so that it's not non-profitable for that attack vector to even exist. But it also has a side effect of everything that the SAO doesn't check. It's not even another attack vector anyway. So yeah.
One other thing I'd like to just highlight as well is that like the level of rigor and the quality of the proposal and the data in the proposal from Ricky and Craig is just exceptional. It's really an excellent read. It took me, 5 minutes to read it, 10 minutes to read it, and I understood what they were doing completely and the rationale. And I like the fact that it's based on data and that it will be monitored afterwards to see if it has the effect we need it to have.
Yeah, and the data is actually quite impressive. So I recommend every one of you that is quite curious to read it. Yeah.
Juan, can you drop a link to the GIPs into the stage chat so we can all take a look at it?
Sure. We'll do after the protocol watch. Yeah.
Thank you.
Cool. Moving on, forum research. We have two GIPs, GIP 26, which is decaying curation tags. There's another small comment by Brandon regarding the specifications of the decay function. These are possible specifications because, as we discussed in that GIP, so far they are just intuitive decisions as to how long the decay function should take and which type of decay function we should use. But yeah, it's also quite interesting if you're interested in curation-related stuff. GIP 25, principal protected bonding curves. There's also a lot of debate regarding how to proceed with principal protected bonding curves. It's a quite important change, and it does require a lot of thought. So I recommend that anyone that's interested in ways to improve curation, that would be the main GIP to look for right now. And if you have any ideas, they are greatly appreciated. Yeah. Moving on to pinboard, I will pass on to, I think, Chris. You're probably going to continue with that, right?
Hello. Yes, let me pull that up. Sorry about that. Okay, so today on the pinboard, I guess just as a recap, the pinboard is for tracking issues that are relevant to indexers and things that we would want to keep top of mind. Really, the only thing on the pinboard at the moment is Aragon 2 and the fact that it is backwards incompatible with Aragon 1. It's something that we'll continue to talk about in Repo Watch and highlight as we move forward. So not much to talk about there. So I think I will hand it back to Abel, who may hand it back to me.
That is correct, but not before I do an introduction to your conversation. So, as some of you are familiar, we are in the middle of a 5-part series of the breakdown of the R&D roadmap for the graph. But today, unfortunately, we had a last-minute dropout of a guest, so we have decided to switch things up. And luckily, we have Zach, who has stepped in for us from EdgeNode to speak about all things indexer selection algorithm, 𝗨𝗲𝗂𝗧𝗏, subsidized query settlement, and then the broader effort to try and increase the quality of service in the network, and many, many other things. And that conversation will be facilitated by the lovely Chris. So, Chris, without further ado, take it away.
Thank you, Abel. It's a pleasure to facilitate this conversation with Zach. Thanks for joining us again, Zach. It's a real pleasure to have you here.
It's always my pleasure too. Thank you.
Cool. So, as Abel mentioned, today's topic of discussion is the indexer selection algorithm. And I'm sure many of us here are aware of the indexer selection algorithm. It obviously impacts all of us. And the team at EdgeNode has been working on some very significant improvements to the ISA, some of which have landed and others still coming down the pipe. And Zach is here to chat through those with us today. So yeah, Zach, what are we covering?
So, like as you said, the indexer selection algorithm, which is implemented in the EdgeNode gateway, is something that we've talked about before, but it's been a while. And with the recent events in the network, it's become more relevant than it ever has been before. So it seemed like a good time to kind of recap what we've gone over, and then talk about upcoming changes about how we're going to improve it. So one of the reasons that it's more relevant these days than when we last talked about it, maybe almost a year ago now, is that a lot of projects are migrating to the network. And that means an increased amount of query volume, which means that indexers need to be paying attention to capturing this query volume if they want to optimize their revenue. There's also a broad effort to increase the quality of service on the network beyond that of what we could provide with the hosted service, not being a decentralized offering. And because of that, and because of 𝗨𝗲𝗂𝗧𝗏 subsidized query settlement, indexers are starting to ask more questions in the forum, right? Some may be selected more often than others. They want increased transparency, and they want to understand what they can do to optimize their chances of being selected. So we'll go over what the ISA is, what it's trying to accomplish, and then what it's going to look like in the future.
Fantastic. I'll just say, as we kind of progress through this conversation, if anybody has questions that come up, please drop them into the stage chat channel, and we'll do our best to cover them when we get to the discussion piece at the end. Zach, let's get straight in. For those that aren't, intimately familiar with the indexer selection algorithm, you mentioned it runs in the gateways, but what does it actually do?
The purpose of the indexer selection algorithm, or ISA for short, is to ensure a great quality of service using the network for consumers, right? We have a bunch of different indexers to choose from. They're distributed across the world. Each of them has different characteristics. When we receive a query from a consumer in the gateway, we want to route that query to the best indexer to serve that user's needs. And there's a bunch of different factors that we look at when making this decision. One of them is going to be data freshness, which is how close is that indexer to the chain head, right? Are they reporting on the latest available information from the blockchain? Another is going to be performance, right, which will be different per indexer and per gateway location due to just the distance that's between each gateway and each indexer. So we want to make sure that we serve that query, query to the user very quickly. So we want to select one with low latency. We want to look at economic security, right? If a indexer were to try and fabricate incorrect information, how much would they be slashed by doing that? That's another thing that we look at. We want to look at how reliable this indexer is, right? If they're experiencing downtime, then we probably want to select another indexer. We look at the price and how this is going to affect the consumer's budget. And just many selection factors, which all go into making this decision. Some of those selection factors are objective and they're part of a shared worldview. So for example, we talked about economic security. The amount that a indexer would stand to get slashed is a fixed amount, and every gateway and every consumer is going to agree on that information based on how much stake they have and the slashing percentage that's configured in the chain. Not only is it objective, but it also does not update very frequently. Other factors, though, like data freshness, are closer to having a shared worldview, where every indexer reports on their status and the gateway believes that at first, but have like a mix of objectivity and subjectivity. So we need to actually make queries to confirm that the indexer has in fact indexed to where they say that they have, right? And if they have misreported on this and they say that they can't serve a query because they're behind, then we'll penalize them for that kind of thing. And then some things are just entirely subjective or based off of many observations that the gateway has to make by performing queries, like performance, right? And that's an entirely local worldview to that gateway. And it's unfortunately some of those subjective things are unverifiable in nature and they can't be audited. But all of them are based on observations. Some observations are free, right, like querying information from the blockchain, and some observations actually require us to make a query to that indexer. Like if we want to update what is our view of this indexer's performance. So we are making all these observations, making predictions about the quality of service that a consumer can expect to receive if we select an indexer. And then putting those predictions through utility curves, which match the consumer's preferences to like how much they value the relative importance of those things, and it models things like diminishing returns and so on and so forth. Finally, just make a selection, send it off, and if it fails, we just loop over this whole thing to implement retries, and that's basically what the indexer selection algorithm is trying to accomplish, and the broad outline of how it's doing that today.
Huh. Yeah, that's super interesting. Thanks for kind of walking us through the kind of methodology. It's a pretty challenging optimization problem. Like what really. So on the one hand, you've got like this ever evolving, constantly shifting market dynamics. Indexers changing prices and going up and down and things like that. And the other thing that strikes me as really challenging is this kind of subjectivity or lack of information completeness. In kind of more formal terms, how have you thought about like framing this problem or modeling it?
Right. So we frame this problem in two ways. One, it's a multi-criteria decision analysis problem, which is a well-studied class of problems that just means we're taking many factors into consideration, and we need to optimize over all of those different factors. And the other way that we frame the problem is as a multi-armed bandit problem, which means that there's an element of exploring the space and exploiting the space, where we want to optimize our utility, but because everything is kind of changing and we don't actually know what the actual values of performance or anything else is at a given time, we need to mix that in with exploring queries. It's a little bit harder than your traditional multi-armed bandit problem because the state evolves over time and even reacts to which selection that you make. And how you're interacting with the system changes that system. So it's technically a multi-armed bandit problem that is a Markov machine and a restless bandit problem. And if words don't resonate with you, that's fine. But if you wanted to dig into more of the academic research into those areas, that would be a good place to start. And framing this problem is actually really important to what kind of service that we can expect.
Right. So who is this bandit, and how did they grow so many arms?
A multi-armed bandit is just I think the terminology comes from slot machines, actually, where if you have a bunch of different slot machines and each of them has an expected payout, you're attempting to pull these levers and you get a reward, and you're finding out over time what the likelihood of different payouts are in these different machines. And your problem is over a given period to maximize the reward that you get by pulling different levers in different orders. So that's what a multi-armed bandit problem is.
I hugely appreciate the serious answer and informative answer to what was a bit of a troll question. So thank you, Zach. So you mentioned that the framing of the problem is important here, and if we kind of recognize that the objective of the ISA is to maximize the quality of service for consumers, what are the implications of framing the problem this way on the ISA's ability to do that?
Right. So framing the problem this way actually creates additional problems for us. So one, because it's a multi-criteria decision analysis problem, it means that whenever you take an action to increase one utility, that you necessarily have to decrease the other utilities. So to give an example of that, imagine that we have two indexers, and one of those indexers has a 1 second latency and is on the latest block, and another indexer is 6 blocks behind but has a 50 millisecond latency. So one is good at performance and one is good at data freshness. So the ISA takes this information and it will essentially result in a distribution of probabilities that you should select each of those indexers. That's going to optimize for the general utility and make sure it's doing exploration and exploitation, all of that. But when you select one over the other, one thing is going to go up and the other is going to go down. So if we think that these indexers are roughly equal, the one with good data freshness and the one with good performance, you might get a 50-50 distribution of queries to those indexers. But no matter how you change that ratio that the ISA outputs, something is going to go poorly, right? So if you change the ratio to increase the average performance, then your average data freshness is going to go down. And if you change it to increase your data freshness, then the average performance is going to go down. And unless you have options that strictly dominate each other, right? If we don't eliminate options that are on the Pareto front or non-denominated set of options, that means that you have to play this balancing act, right? And then there's
it's all trade-off.
Right, it's all trade-offs, and there's a limit to the quality of service that you can achieve when the ISA just selects an indexer. Another implication of the way that we frame the problem as a multi-armed bandit problem is that whenever you explore, your consumers are going to see a bad quality of service. So imagine, for example...
Zach, sorry to interrupt, because you've used this explore and exploit terminology, and I wonder if you could provide a little bit of context for that, and just to go back to what you were saying earlier, how the gateway has this kind of mixed like objective and subjective view of data, and some of that subjective data is based on observations. And some of those observations are free, but others, require facilitating queries. Is that what we're talking about when you say exploring?
Right. So let's take an example. Imagine that an indexer is experiencing some downtime, right? You don't want to have, say, a request to that indexer be observed as failed, and then just ban that indexer from receiving requests forever. Instead, you need to have a model that estimates the probability that that indexer is still experiencing downtime, or has like a random failure rate of queries, both historically and presently. And so as time elapses, basically as your information decays, then you have a decreased confidence in the amount of utility that you would get out of selecting that indexer, right? And in order to increase your confidence to ensure a good quality of service on future queries, then you need to explore the space a little bit and choose what would otherwise be suboptimal selections.
And those selections are suboptimal because the models, making those utility predictions are working with data that is old. But in order to update the data, you kind of need to explore. Am I getting this right?
Right, old and possibly stating that it's likely that the indexer has some bad problem, right? So if we see that the indexer has been down for 5 minutes, that doesn't mean that they'll be down forever. But if you wanted, to optimize that single query for its utility, you might select a different indexer. But if you want to check if that indexer is still down, then you need to send them another query.
That makes sense.
Right.
Sorry for derailing you. You were talking about the multi-armed bandit framing and its problems.
Right. Whenever you increase your exploration of this space, what you're doing is to ensure that future requests have a good quality of service. But that's not very nice for the poor consumer that actually got routed this exploration query, right? Like to that consumer that gets served a query, we serve a query to an indexer that might still be down. They're not happy about ensuring quality of service for future consumers, right? That's not very happy for them. So this with the vast scale of queries that the graph serves, that means that even with very low probabilities, even if we explore the space very rarely, it can lead to a lot of bad customer experiences, right? If we have 1 billion queries in a day, say, and you have like some very small fraction percentage of those queries going out to check if indexers are still down, well, then a lot of people end up feeling the impacts of that. Even if it means higher quality of service overall. And so in that way, working on the gateway is kind of like working on a trolley problem, right? If you get to choose what kind of a villain that you want to be for that day. If you pull this lever, then a few people suffer a lot and many people suffer a bit less, or you can pull another lever and the business team at Edge and Node is going to come knocking on your door, or it's trade-offs, right?
Right. Okay. So, I like where to from here? It feels like that's a pretty hard problem. When you frame it that way, how do we get the network quality of service to a point where it's outcompeting centralized services, that are delivering, 5 minutes of downtime a year?
So taking a step back, I want to be clear about the quality of service as it exists today and where we're at. So I've painted a picture of sort of the most complicated aspects of this problem, or the most difficult hurdles to overcome. But and that gives like a pretty pessimistic view, right? Because you have to take a pessimistic view in order to solve the problems. But in reality, the ISA is doing a fantastic job, I think. It's exceedingly fair to both indexers and consumers, and it's a very optimized algorithm that does a great job of balancing the quality of service needs for consumers with the network's need for decentralization and the indexer's need for fairness and query fees, and balancing all these concerns. So we're doing like a good job of balancing those trade-offs. But I think with some more sophisticated methods, we can get better marginal gains. And I want to recognize, a lot of the people who have put a lot of effort into making sure that we got where we already are today, which is a very good quality of service. First, Brandon from 𝗨𝗀𝗃𝗀𝗀 for giving us an initial write-up of how to frame this problem, and basically without that write-up, we'd be nowhere. Indexer selection would probably have a very bespoke and silly method of doing things, but he really framed the problem to give a unified algorithm for all of these utilities, and that was great. Also, shout out to the data science team, who's provided a lot of insight into the performance of the network and how that has evolved over time. They allow us to continually monitor the situation. And also Theo from 𝗨𝗀𝗃𝗀𝗀, who has implemented many ISA improvements over the last year, including the REST rewrite, which improved the information model of the ISA. And he's always willing to jump in and debug quality of service problems. So even within that framing, we've gotten very far over the last year. We've overhauled all of the utility curves. We've moved away from stake-weighted selection, which used to favor large indexers or even large clusters of indexers, even if they were on the other side of the globe, to a utility-first selection method that still provided the level of Sybil resistance that we want from stake weighting. Like I said, we've rewritten the gateway in Rust and just done all the stuff, but we're ready to take it to the next level. And so where we're at today is maybe we can observe that for a subgraph, 99.8% of queries to that subgraph might meet our quality expectations, but we want 5 nines, right? We want 9.9999% or even better. And the obstacles that we have had in the past of getting there are really the framing of this problem. Just to recap the most important points here before moving on to how we're going to fix it. Because it's a multi-criteria decision analysis problem, right? Increasing one metric must decrease another. And because it's a multi-armed bandit problem with restless characteristics, that whenever you explore the space to add observations, somebody gets a bad quality of service. But if you don't do that, then everybody gets worse quality of service, right? And so the first kind of grain of an idea that ended up being the wrong idea, but leads you into the right idea, is that, hey, maybe when we're exploring, we could just select 2 indexers, right? So for example, if we have an indexer with low performance or a low confidence in the performance measurement that we have, we might want to pair that indexer with another indexer that has a high performance, so that the query overall, has a good chance of getting through and getting through quickly. But I didn't implement that for a very long time, and the reason is that if you think about it and try to go through all the cases for things that you want to implement, there's just a lot of special cases, right? To give an example, we gave the example of having low performance, where if or say low reliability, where if you might think, hey, this utility is low, so why don't we always look at a low utility and then pair it with another indexer which has a high utility in the same category? That actually gives you the wrong result in a lot of cases. So if you look at a utility like price, this gives you the opposite of what you want to do, right? If you selected a high price indexer, then selecting a low price indexer doesn't actually help. It just makes the problem worse because you're spending more money, and that's the thing you wanted to avoid. And if you have, say, differing values for data freshness, you get into this weird situation because not every indexer selected could in fact serve the same query. So adding another indexer doesn't necessarily fix the problem. And I started listing out all these different cases. After getting to about 10 of them, became overwhelmed with the impact that this was going to have on the ongoing maintenance burden of the gateway. And I thought it would create such spaghetti code that the result was going to be very difficult to understand, debug, and ultimately improve, and maybe even creating a cap on the quality of service that we might get to, because it would limit further contributions to the ISA because of that complexity. It didn't feel right. So I sat on the problem for a long time. And it's one of the nice things about working at Edge node and on the graph is that at any given time, there are several high impact problems that anyone can be working on. So it's not bad to let a problem simmer and work on another problem for a while. And then over time, there was a key insight that's going to form the basis for the new indexer selection algorithm. And the insight is this. You can take two indexers and combine all of their observations in a way that creates a profile for a new indexer. And that new indexer, you can run all of the same utility curve checks on that and get a combined utility from that indexer. So as an example of this, consider an indexer that would fail randomly for 1 out of 200 requests. That's a 99.5% success rate. That's good. It's not great. And we have another indexer that randomly fails in 1 out of 125 requests, which gives you a 99.2% success rate. But if you select both of these indexers, then the chances that both of them will fail randomly is 1 in 25,000, which gives you a 99.996% success rate. So we went from 2 nines of reliability to 4 nines of reliability by just combining these indexers. And whenever you combine indexers, including your new imaginary indexer that you just created, the reliability utility always increases, right? Until at some point you start to find diminishing returns. And it turns out that all of our utilities have a fairly straightforward way to calculate the utility of the combined profile of indexers. So this is important because it removes all of those special cases. Remember, for example, like the weird case of price, where we didn't want to add another indexer which had low utility in this category because it makes the problem worse. If you have a low utility of price, so it's going back to the model, right? If in this new model of combining indexers and then calculating the utility of the new imaginary indexer, the price utility has a straightforward calculation. You just calculate the utility of the sum of the prices, because if you send the query to both indexers, that's what you're going to end up paying, and that has a utility. So it's not a special case anymore. It just runs through all of our same utility calculations. And then you can take a step back from there once you've done this for all of your different selection factors, and look at the problem now as selecting from new options of imaginary indexers that are combined other indexers. So if you have, say, those two indexers with 99.2% success rate, 99.5, we can use this model to create a third indexer out of thin air, so that we have the 99.2% price and say 1 GRT, 99.2% reliability and a price of 1 GRT as an option as indexer A, or indexer B with 99.5% success rate and a price of 0.2 GRT. Or we can invent indexer C, which is the combination of the two, with a 99.996% success rate and a price of 0.3 GRT, right? And taking those, now the ISA just has 3 options to choose from, and we can use our normal selection method to figure out which one we should do. And you can extend that even further, rather beyond 2 indexers, to create a bag of indexers and keep adding indexers to the bag in a way that the one that you add next complements the set of the existing indexers that you've chosen. So you just keep stuffing indexers into the bag until either you run out of indexers because you've added all of them to the bag, or the marginal increase in utility that you would get from adding another indexer is less than the marginal decrease in utility that you get from the added price or the added budget. Basically, like if you run out of money, you have to stop. And then, once you have this bag full of indexers, you send off all of those requests simultaneously, and that's going to form the basis of our new indexer selection algorithm.
Wow. Okay, we covered a lot there. I'm also conscious we're 2 minutes before the top of the hour. I wish we had time to unpack some of that and chat a bit further about it. But before we end, are there any kind of broad insights that's kind of come out of this? What sounds like quite a long process of thinking through the problem, trying different solutions, and ultimately landing up with the what would you call it? The bagged indexer approach?
I guess, yeah. I don't have a name for it yet, unfortunately. But broad lessons here that I find echoed in a lot of sort of engineering problems that we have to solve and research problems. Sometimes it can be okay to pause, right? If you don't feel that you have the correct answer yet, implementing the wrong thing can take you farther away from implementing the correct answer. As long as you have other things that you can work on, and as long as you have all the fires put out, right, then it can be okay to wait on something until you have the insight. Another thing is that the best ideas are really obvious in retrospect, which whenever we have ideas like this, I have just mixture of excitement about the new ideas and the potential that it can bring, and just this feeling of being really dumb for having not noticed it before. Because if you describe this, it seems really obvious, right? But it wasn't obvious, at least to me, for a very long time. So I felt, dumb. But I would just encourage people not to feel dumb when they make these kind of observations, because that's just the nature of the game. Another thing is that complexity is something that you need to budget for, right? One of the reasons that we didn't do the other change where we would, try to add one indexer and have a bunch of special cases is because that would have created a ceiling for the quality of service that we might not be able to get past, because no one could understand what was going on to bug it, and eventually make improvements. So, make sure that you're putting complexity in the right place. And then the last, and maybe the most important, is that there is always a solution space outside of just beating a problem into submission, right? If you describe the problem as MCDA and multi-arm bandit, then there are optimal solutions to these problems. But sometimes the best outcome happens if you change the problem in such a way that it opens up the solution space to create new solutions and better outcomes.
Zach, thank you so much for joining us. It was a fantastic conversation, certainly one that I will listen to again. And I'm sure many indexers will too. Lots of, I would even say some alpha leaks in there. So thank you again for joining us, and I hope to have another conversation with you like this soon.
Thank you. It's always fun.
Indeed. Back to you, Abel.
Thank you so much. I'm just picking up the pieces of my brain on the floor after that mine explosion. That was insane. Recording coming out soon for all those who want to listen to this again. Just going to wrap up with the POAP. So it is indexer POAP 59. That is all lowercase, indexer POAP 59. There you have it, ladies and gentlemen. Another fantastic episode of IOH. I certainly learned a crap ton, and I really hope you guys did too. Without further ado, I hope to see you guys next week. Take care.
Bye everyone.
Cheers, guys. Take care.
Bye, everyone.
Bye, everyone.
See ya.